Okay, I think we should get going. Thank you all for being here today. We have two very nice presentations for you on the variabilité climatique en montagne, enjeux et particularités regards croisés Alpes et Himalayas de Judith Eeckman et Climate Change in Nepal, Himalayas, Current State and Future Prospect from Professor Dawadi. Just a reminder to keep your video and microphone off during the presentation. The seminar is recorded and you're always able to see the previous seminar on our YouTube page. The presentation will be about 20 minutes each, plus about 10-minute questions. And we will reserve time at the end as well for both speakers. You're most welcome to ask questions in English and French, and I'm happy to translate as needed. So we will start today with the presentation of Judith Eeckman. Elle est chercheuse post-doctorale en hydro-climatologie à l'Institut de Géographie et de Durabilité de l'Université de Lausanne. Dr Eeckman a obtenu un diplôme d'ingénieur en mathématiques appliquées et en informatique et un master en géographie physique. Sa thèse de doctorat portait sur la caractérisation des systèmes hydroclimatiques des petits bassins versants de haute montagne dans la région de l'Everest, ainsi que sur leur sensibilité au changement climatique et au changement d'utilisation des terres. Ses précédents travaux postdoctoraux étaient consacrés à la simulation de l'humidité de sol dans le contexte des crues soudaines dans la région méditerranéenne. Dans le cadre de son poste de première assistante à l'IGD, Dr Eeckman mène des recherches sur la caractérisation du risque de sécheresse à l'échelle des Alpes vaudoises, ainsi que sur la spécificité des territoires de montagne face à ce risque. Par son parcours professionnel, elle possède de solides compétences en modélisation hydroclimatique, programmation, statistique, gestion de données, ainsi qu'en cartographie et aménagement du territoire. Vous ne serez pas surpris d'apprendre qu'elle est également une grande passionnée de la montagne. Alors, on vous écoute, Madame Eeckman.
Thank you, Nicolas. Thank you very much. I'm very happy to speak together with Binod Dawadi today because that gives me the opportunity to present you something about a cross view about the two terrains I had the chance to work on previously. That was the Alps and the Nepalese Himalayas. So I'll try to share my screen. Here. I hope everything is all right.
Yeah, very good.
Yeah. Okay, thank you. So let's go for around 20 minutes about the presentation on the hydro-climatic variability in mountainous region, and just as I said just before, with a comparison between the Swiss Alps and the Nepalese Himalayas. So first, I wanted to present you the current and the general hydroclimatic condition that we can find in this region, in mountainous region, and what are the common points between mountainous regions, and somehow some of the future projection given by the last IPCC report. So in the very, very general lines, these are the hydrological regimes you can find in mountainous regions, so in the Swiss Alps and the Nepalese Himalayas. So about precipitation, so that means solid and liquid, so rain, more snow, precipitation. In Switzerland, we have a pretty homogeneous amount of precipitation along the year, with, of course, a decrease of precipitation during summer, and the peak of discharge in general in the rivers of the Swiss Alps will be around June or the end of the spring. On another side, the climatic regime in the Nepalese Himalaya is very, very different because we are there under a monsoon regime. That means that the very majority of the annual precipitations happen during the 3 months of monsoon, so that is about June, July, and August. with even more during July and August. And of course, the peak of discharge happen in general during these 2 months of discharge. So with a part of this very general typical regime, we can find very local differences, of course. But what we can see in commonly between these two regions are the contribution of snowmelt and glacier melt, because we are in mountainous regions. So again, with general line, the snow melt and the glacier melt contribution could be summarized just like this one. The snow melt in the Alps happens in the spring, whereas the glacier melt happen in maturity during the summer when the temperature are the highest. And on the other side, in the Himalayas, the snow melt happened also during the spring, but with a longer period of snow melt. This is due to the largest elevation range in the Himalayas compared to the Alps. And the glacier melt also happened during the monsoon months, which are the maximum of temperature. So these two contributions are in mountainous region very essential to understand the dynamic of the hydrological region. And here I just wanted to show you two particular periods that we have to be aware of. Are the periods of hydric stress that we can find in these two regions. So in the Alps, the hydric stress will be more important at the end of the summer when the storage in the different compartments of the hydrological cycle are very low. And on the other side, in the Himalayas, the hydric stress will be more important in spring, at the beginning of the melt period. So these two periods are very important when we look at human uses of water and what is about consumption. And as we will see before, these two periods of hydric stress are going to evolve when we look at the climate change. So speaking about climate change, that's a good transition. I wanted to present you some particular results of the last IPCC report, so the sixth one, right? So here I just present the result for the worst scenario of the report, which is the fifth one. Just because I think it's the more relevant. And here I present you the evolution of temperature in the two regions that are defined by the IPCC, that are the Western and Central Europe and the Tibetan Plateau. And for the two regions, it's possible to extract to extract a mask that only represent the mountain areas. So that is the result I'm presenting you. So here you can see the evolution of monthly temperature since the middle of the last century up to 200 and 100. And what we can see here, and what is very interesting for us as a hydrologist, is that we can see a strong increase of monthly temperature during spring. And that will be very interesting for water cycle, because that means an earlier snow melt in mountains. And this will very strongly influence the water cycle in mountainous areas. And this is also observable in the two regions. That's important. Another projection I wanted to present you about the snow. So here you can see the evolution of monthly average volume of snow in water equivalent for the whole northern hemisphere. So that's a large region, but the IPCC report show that the variation inside this northern hemisphere is pretty low. So it's almost the same results everywhere in the hemisphere. So what you can see here is that both figures here show that in the recent year we get less snow and very less snow during spring, and this result is visible at the same time when we look at annual snow volume. So there is just less snow in general. It's also visible in the snow-covered surfaces. That means that less surfaces are covered by snow in general, and that will change for the issue of albedo, but that's another question. And also, what I'm very concerned of is the change of the change in the timing of the snow melt, as I said just before, with a strong a melt of the snow happening way earlier. So this projection of the last report, like last IPCC reports, are interesting, and now we can look at the possible impact of this prediction on hydrological cycle. So if we try to summarize that in the very main lines again, so here is the previous, the actual current precipitation regime we can find, and these are the summary of the predictions. So in the Alps we will get less water, less precipitation in summer, and there is also a few increase of precipitation during winter, but this is associated with a lot of uncertainty, so I won't speak about that. And on the other side, in the Himalayas, we will see an increase of the rate of the monsoon. So that means more water in a fewer time. So the 2 months of monsoon, so July and August, will be more rainy, whereas the June and September, just before and after the monsoon, will be less rainy. And that will also change the hydrological cycle. So when we look at the two contribution of snow melt and glacier melt, as we discussed before, so that with pointed lines, they are the current dynamic, and the continued line is somehow the kind of a projection of what could happen to snow melt. So snow melt will happen earlier in the two regions, and also will decrease in volume. And for the glacier melt, it will also happen earlier because of the increase of temperature. And this result is very, very variable, locally variable. But in the Alps, so the amount of snow melt, of glacier melt, sorry, will definitely decrease, and even maybe disappear at some point where the glacier will disappear. And in the Himalayas, since the glacier are very huge compared to the Alps, the contribution of glacier melt will somehow increase for a while, and then also will disappear when the glacier will also disappear. So the question when we look at these two contributions is now, what are the impact on discharge? And this is actually our work as hydrologists, is to understand the impacts on surface water. And to answer this question, a main system I'm really interested in is the importance of watering the soil in mountain. Because in mountains, the soils are very interesting because they are mainly composed by unconsolidated subsoil, mainly with landslide, created by landslide or ancient moraine or very big blocks. And between these blocks, you can find micropore that can store a lot of water. And on top of that, on this big blocks and macropore, you will find very shallow soils, and many works show that these soil in mountain are mainly sandy. So that means a fast infiltration, that a fast infiltration is possible in mountain. So these processes are very poorly understood in mountain because they are very difficult to work on actually. So the question we're asking right now are what could be the storage capacity of the soils in mountain, and what could be also the delays that are caused by the infiltration of the snow melt in the soils, and also what could be retention time in moraine deposits. So this is very crucial for the question of surface water availability. So now I wanted to present you, I hope I'm not too late, I can't see the time actually. So I wanted to present what we are doing right now actually, what are the challenges for understanding mountain system at a very local scale in mountain. So in general, when you do meteorology or climatology in mountain, you have to know that there is a double difficulty in mountainous regions that are the climate is very locally variable. It depends on from one valley to another. It could be very different. And there is also a low density of the measurement network. There is less weather station in mountains than in down centers of the city. So in this context, yes, I wanted to present you, to introduce you to catchments I am particularly a fan of. So two catchments I had the chance to work on. So on the left you can see the Vallon de Nant, which is located in the Vaud region in Switzerland, and on the right you can see the Taoche River catchment, which is located in Khumbu in Nepal, so in the Everest region. The Vallon de Nant is around 13 square kilometer, whereas the Taoche catchment is 4.6 square kilometer, and the elevation range is even larger in the Taoche catchment than in the Vallon de Nant. And what you can also see on these two pictures are the mesh, so the grid, the line, the gray lines. They are the resolution of the best climatic model available for the region. So in Switzerland, so Meteo Suisse has the Cosmo 2 model. There's also Cosmo 1 that I won't speak here. So the Cosmo 2 model has a 2.2 per 2.2 kilometer resolution, which is very, very fine, one of the finest in the world. And here you can see that the Vallon de Nant is included in an almost 4 or 5 mesh of that. And on the opposite, the best climatic model you can find for the Nepal area is the MERA 2 mesh model, sorry, which has a mesh of around 50 square kilometer, 50 by 50 square kilometers, sorry. And so you can see that the Taoche catchment in this mesh is very small. You can also see the red points that are the meteorological station I worked on in the two studies in these two works. So you can see here that estimating climate variable in Switzerland or in the Everest region is a very different issue because the data are very different. And I wanted to also present you an example of a current research we are doing in Vallon de Nant, so in Switzerland. That's what I am working on right now. So we have 3 meteo stations installed in the Vallon, as you could have seen just before on the map. And it's a lot to have 3 meteorological stations in such a small area. We also have a station to measure water level at the outlet of the catchment. This last winter, we installed an instrument which is very precious to measure snow melt in one point of the catchment. So with this instrument, we get time series of snow melt on the floor. And last, we have a network of soil moisture measurement at different depths in different points of the catchment. And here it's very quickly some example of the results we get from this experimental network. So the first line, the first graph, is the evolution of soil moisture at the 3 different depths. The second graph is the evolution of water depth or water level, sorry, at the outlet. And the third line is the evolution of the snow density and also the snow water equivalent on the last layer of the snowpack. And it's very interesting to look at this data because, in particular, during the spring melting period, so in red here, you can try to figure out the link between these two variables. So you can see that as soon as the melt starts in beginning of middle of March, sorry, you can see a reaction of the soil moisture and also a slight or low increase in water level. But this is, first of all, an ongoing research. So this is that's data I just get 1-2 weeks ago. So I won't present you any more results about that. But I was very happy to present you such a result. So that gives you an overview of what are research in mountainous areas right now. So I will now show you quickly some conclusions. Sorry. So the main conclusion would be that both in the Alps and in the Nepalese Himalayas, you can find snow ice hydro system with snow melt and ice melt contributions. One of the main impacts of climate change in mountain are that the snow is going to happen earlier in the year, and this will happen in the 2 regions. Also, the storages in the soil have a key role for the availability of surface water, but the processes in soils are very poorly understood in mountains. It's important to know that estimating climate variable at the very local scale is always hard in mountains. And last, I would like to see that local case studies are always needed for understanding mountainous systems. So that will be all, and I hope I've been clear and fast enough. Thank you.
Binod Dawadi holds a PhD and postdoctorate from the Chinese Academy of Science in Beijing and works in the field of climate change and international cooperation. He's a visiting professor at the Interdisciplinary Center for Mountain Study of the University of Lausanne during the month of May of this year.
I'm very happy to be here with you in this program, and I'm very happy to be part of this climate series. So let me start with my presentation. The Nepal, with its surrounding countries, are sharing the highest Himalayas and Tibetan plateau in the world. These regions occupies high amount of the glacier than the North Pole and South Pole. Therefore, this region is called the third pole region by many scientists. These third pole areas are very important because this area covers 5 million square kilometer of area with the elevation of higher than 4,000 meters by average. Not only with this, the Asia's big rivers are being generated starting in these regions and feeding the billions of peoples downstream. Please, next one. As we talk about the Nepal Himalayas, we all know that Himalayas is extending from Myanmar, India, Bhutan to the east. Then in the central, Nepal is around here. Then India, Pakistan, and Afghanistan. Among the 2,400 kilometer long Himalayan region, Nepal lies in the central Himalaya, and by the length, it covers 850 kilometers. So it's in the central Himalaya and covering the most part of the highest peak of the earth. As we know, 8 out of 10 highest peaks of the earth are there in the Nepal. If we see the topography of Nepal, in the southern area, we call it plain area. Within this 200 kilometer, we have the large variation in the altitudes from 60 meter to more than 8,000 meter. Please, next one. When we talk about the high altitudes climate, of course, the Nepal, the lower elevation, there are several stations, but if we see the high Himalayan region, higher mountain region, there are lack of meteorological station for the measurement in the one hand. In the other hand, like Judith also shows that the climatic models also difficult to capture the complex topography of the mountain, Himalayas of the mountain. So it also one of the difficulties to study the climate change in the Himalayas. Please, next one. Well, seeing the distribution of the temperature, as we mentioned in the previous slide, lower elevation side, it's called the Tarai regions, much more temperature. And then as we go to the high mountain region, temperature goes on decreased. And if we see the distribution, this March, April, and May, June, and April, these are the month with the highest temperature. And this is the climate increase scenario in the Nepal. Next one, please. And this increase in temperature shows that climate changes are shifting higher in altitudes and glaciers are melting and the frequency of precipitation extreme is increasing in the country. And the modeling has suggested that the number of people annually affected by the river flooding could be more than double by 2030 as a result of the climate change, and at the same time, the loss due to the flooding would be triple. So we have such kind of the devastating scenario already been seen. Please, next one. This is the future projection of the climate in the Himalaya. Just I like to highlight that in comparison with the lowland Tarai, high Himalayas, there is high degree of the change within the different scenario. Next one. Please go on. So we see the changes in the glacier, some changes in the Mount Everest region, the top of the wall. If we compare these two pictures, it's clear that the impact of the climate change already there in the mainly in the glacier melt. Please, next one. And this is one of the examples that we are conducting the mass balance research with the IRD France and Sangre Nup Glacier in 5300 to 5700, Pogde Glacier and Mira Glacier. They all are depleting, the rate is high. Next one. Just this is the mass balance studies, maybe the same with the Swiss Alps. Everywhere the glacier mass balance, they are showing the negative result. Please, next one. If this continues, SKS research shows that SKS glacier volumes will be declined substantially by 2100 in the different RCP scenarios. Next one. If we see the distribution of precipitation in the Nepal Himalaya, we found the variability. If we see the central part, this is the highest precipitation zone in Nepal, around 5,500 millimeter. But just opposite of this place, there is lowest precipitation zone, the 250 millimeter only. And more than 80% of rainfall occurs only in the few days of the monsoon season, we call this June, July, August, September. This is the monsoon season. Within the few days of this monsoon season, there is the high precipitation. The research are showing that precipitation amount is increasing, but number of days of precipitation is decreasing. When within the limited days, more precipitation, it creates the problem of flooding. And in this figure, I like to highlight the differences of the distribution of precipitation. If we see from low elevation up to some certain level, precipitation goes on increasing. After that, precipitation goes on decreasing. I think it is one of the dissimilarities with the Alps. Maybe in the Alps, high elevations are getting more precipitation, but in the Himalayas, high altitudes getting less precipitation. Therefore, this is one of the things that we have this dissimilarities within the similarities. Please, next one. And these kind of the intense precipitation within the certain time creates the problem of flooding, and this flooding is impacting many infrastructure, and just last year 3 billion Nepali rupees physical damage was there only in the hydro sector in one event. Because while designing such a project, people were not expected such kind of the unexpected event, and also the drought is also affecting the agriculture sector of the country. There is some serious visible impact in water resource, and which already creates the climate refugees. This is one of the example, drinking water problem in many hilly areas, because less water in the spring, they are depending on the spring water. Some springs are about to dry up, and some already dried, and it's creating the drinking water problem. And a new class of the climate refugees is already been observed, already been found over there. One example is Deha village, which is in the Upper Mustang, and Samjong village, which is also in the Upper Mustang, which is very less precipitation zone in Nepal. There, all the water resources were getting dry up, and this village lies in the 3,930 meter, this Deha village, and Samjong village is there in 4,100 meter from the sea level. These both places, water get dried, and due to the lack of water, and these villages were resettled in the nearby places. So the government is clarify this. This is due to the climate change, and the things of the climate refugees is already seen in the country. This is one of the serious impact, visible impact of the climate change that we have seen. So in our region, what we believe is lack of interdisciplinary research in the various aspects of the climates and its impact. For example, some people study the climate change and they give the trend, but what would be the impact of this change in the agriculture, in the society, in the people's livelihood, in the economy, or in the different sector? It is lacking over there. And also the understanding of the linkage between cryosphere, atmosphere, monsoon, and hydrology is also important, because Himalayan region, due to we have the complex topography. So understanding the relation between these is also one of the study area for the future. And understanding the extreme and seasonal shifts in the high mountains region is also one of the rare studied area. And uncertainty of the climate projection and their possible impact in the different sector, it is also one of the rarely studied areas. Since just in the previous presentation, Judith also explained that it is difficult to capture by the recent global models in the complex topography of the Himalayas. And of course, the climate change adaptation policies, plans, and program is the recent needs of the country. Since we are small countries in between two big countries, we have very small contribution of GHG, and the options that Nepal has only the climatic adaptation. Therefore, need to have the collaboration among all. Just this is one of the example. Just the researchers, academia, and policy people engagement in the programs. So I like to say that Nepal is an ideal country for the research. Just this is a map of Nepal. If we see it's the topographical distribution from within this 250 kilometer, we have less than 60 to more than 8,000 meter of the elevation. And this large elevation is creating not only the variation in climate, but variation in the biodiversity. And we have the 123 different languages, 125 ethnic groups. So Nepal is the natural laboratory for the climate, biodiversity, culture, and related impact studies. Therefore, what I would like to say is best utilize this natural laboratory that provided by the nature in Nepal. Next one. So to best utilize, what we can do is with all the EPFL or Lausanne University or climate network, we may have some collaboration for the studies. We may create the joint research project and upgrading the academic curricula which you have already here may be useful for us. We may go for the academic mobility, joint workshop, and so on. These are the programs that we can do combinedly. This next one. Therefore, finally, I would like to say that climate change in the Himalayas is more than the global average with some visible impacts already there. Interdisciplinary action is urgent to understand the climate mechanism and its impact in the different sector to shape the mountain ecosystem and livelihood. For that, I'm very interested to have the collaboration among the researchers and academic communities within the climate, our EPFL and Lausanne and TU, and also the practitioner around in the different mode. And I would like to request all the scientists to best utilize the open natural laboratory provided by the nature so that we can contribute jointly to achieve the SDG goal. Please, next one. And I have seen some of the funding agencies from the Switzerland. Swiss development cooperation is also giving the priority in the climate change, and also it has several programs, this cooperation with the developing countries. And in Nepal, there is a SDC office, and it is also giving the priority in the extreme events. So we can make the connection over there. And as I have seen that Swiss Academy of Sciences and Swiss National Science Foundation is also having the different program for the cooperation with the developing countries. Please, next one. Therefore, finally, I would like to request you to work together between two mountainous countries, connect yum to yum in the knowledge, ideas, and resources. Thank you very much.